Welcome everyone to this session on control charts for discrete data. As part of our broader Six Sigma and Quality Control Toolkit, today we'll focus on understanding how to monitor processes where the data we collect is count-based or discrete in nature. We'll cover key types of control charts like P charts, NP charts, C charts, and U charts, and understand where and how to apply each. These charts are particularly useful when dealing with things like the number of defective items, the count of errors, or the frequency of events within a set time or sample. Our objective is to ensure that even when dealing with non-continuous data, we can still effectively track variation and identify whether a process is in control or needs intervention. In this slide, let's begin by understanding why we use control charts for discrete data. First, discrete data refers to count data, things we count, like the number of defects, errors, complaints, or nonconformities. These are not measured on a scale, but counted as whole units. Now, why do we need control charts for this type of data? Because they help us answer critical quality questions. Is the number of defects increasing over time? Is our defect rate stable? Are there any signals or patterns suggesting special causes? To make this relatable, let's use a simple analogy. Imagine you're counting typos per page in a printed book, or tracking how many deliveries are late each day. You're not measuring a value on a scale, like height or weight, you're counting occurrences. That's what discrete control charts are designed for, to monitor how these counts behave over time and determine if the process is in control. So in short, discrete control charts are your go-to tool when dealing with count-based attribute data. Let's now look at when you should use discrete control charts. Discrete control charts are most appropriate when you are counting occurrences rather than measuring something on a continuous scale. You should use them when you're counting defects or events, not measuring dimensions like weight, time, or length. Your data reflects counts like defects per unit, per batch, or per opportunity. And importantly, your data consists of whole numbers like 0, 1, 2, and so on. Let me share some real-world examples to make this clearer. Say you're tracking the number of scratches on a car before delivery, or the number of customer complaints received per day, or even the number of data entry errors in invoices. In each of these cases, we're counting discrete events, which makes discrete control charts the right tool to monitor and improve these processes. We'll soon dive into the different types of these charts and learn how to use them effectively. Let's begin exploring the first of the four main discrete control charts, the C chart. A C chart is used when we are tracking the number of defects per unit. It's important to note that we use this chart only when the sample size is constant, meaning we inspect the same amount of product or area every time. Key features. The chart plots the count of defects per inspection unit, not whether the unit is defective or not, but how many defects are found. It works on the assumption that defects follow a Poisson distribution, a statistical distribution suited for count data. It's essential that each sample or inspection be of the same size or area, otherwise the results will be skewed. Example. Let's take a manufacturing example. A quality control team inspects 100 circuit boards in each shift. They count how many soldering defects are present across those boards. So, every shift, the number of defects counted becomes a data point for the C chart. It helps us track whether the defect level is stable or if there are signals that require us to take corrective action. To summarize, use a C chart when you're counting the number of defects across a consistent inspection volume. Let's explore the second type of discrete control chart, the U chart, which is used to monitor the number of defects per unit, especially when the sample size varies. Key features. The U chart is appropriate when defects can occur multiple times per unit, and sample sizes are not constant. It plots the average number of defects per unit over time, allowing us to monitor the process's stability. Unlike the C chart, the U chart accommodates varying sample sizes, making it more flexible in real-world scenarios. Example: consider a scenario in a printing company. Each day, a different number of pages are printed. Quality control inspects the printed pages and counts the number of printing errors. Since the number of pages varies daily, the U chart is ideal for tracking the average number of errors per page over time. By using the U chart, we can determine if the printing process remains in control despite fluctuations in daily output. In summary, the U chart is a valuable tool for monitoring processes where defects per unit are of interest and the sample sizes are not consistent. Continuing with the U chart, let's look at more details and real-world examples to reinforce the concept. The U chart plots defects per unit of inspection and is highly valuable because it allows for variable sample sizes. This means you can use the U chart even when the number of items or the area being inspected changes from one inspection to another. What makes the U chart powerful is that it normalizes the data, meaning it adjusts for those varying sample sizes to give you a consistent basis for comparison. Example from manufacturing. Imagine a textile mill where the fabric rolls being inspected are of different lengths. The team records the number of defects per 10 meters of fabric. Since roll lengths vary, the U chart is the correct tool to track and analyze defect trends effectively. Example from services. In an airline, they track baggage claim complaints per 100 passengers. But each flight may have a different number of passengers, making the sample size inconsistent. Again, the U chart steps in to handle this variability by calculating complaints per passenger count, enabling fair process monitoring. In both examples, the key is normalization. The U chart adjusts for sample size differences, ensuring that we can still monitor the quality or performance accurately. Next, let's look at the NP chart, which is used to track the number of defective units in a sample. Unlike the U chart or C chart that track number of defects, the NP chart focuses on whether the item itself is defective or not. It's a binary outcome: pass, fail, good, bad. When to use? Use NP charts when you're tracking defective units, not the number of defects per unit. Each unit is simply evaluated as acceptable or not. And very importantly, the sample size must remain fixed throughout the data collection. Key features. It plots the count of defective units over time. It's ideal for binary classification tasks like yes-no decisions on whether an item passes inspection. This chart is very common in scenarios where inspectors simply mark products as defective or non-defective based on a quick evaluation, and the sample size is consistently the same for each inspection batch. For example, if you inspect 100 items every day and record how many are defective, the NP chart will help you monitor if that defect count is stable or shows signs of a problem. We'll see how this differs slightly from the P chart, which also uses pass-fail data but adjusts for varying sample sizes. Let's now look at some practical examples of where the NP chart is used. Manufacturing. Example: an assembly line inspects 100 widgets per hour. It simply counts how many of them are defective. Since the number inspected is always 100, the sample size is fixed, making it ideal for an NP chart. The chart will help us track the number of defective widgets per hour to see if the process is stable or showing variation. Service. Example: a bank audits 50 loan applications every week. They check for completeness and note how many have missing documents. Again, since the audit size is always 50, we use an NP chart to plot the number of defective applications, AEE, ones with missing info. Both examples highlight the core rule of using NP charts. You have a fixed sample size, and each item is judged as defective or not, a binary outcome. So anytime you are evaluating how many items failed in a fixed group, the NP chart becomes your tool of choice. Now let's move to the final type of discrete control chart, the P chart, which is used to track the proportion of defective units in a sample. When to use a P chart when you're evaluating units as defective or not. So again, a binary outcome. However, unlike the NP chart, the P chart is used when the sample size is not constant. This makes it ideal for real-world situations where your inspection size can vary, say 80 units one day, 120 the next. Key features. The P chart plots the percentage or fraction of defective units in each sample. It's designed to adjust for varying sample sizes, which means even if your inspection volumes differ, you can still monitor trends accurately. Think of the P chart as an extension of the NP chart. NP chart equals counts of defectives when sample size is fixed. P chart equals proportions of defectives when sample size is fixed. Size varies. So if your quality control team inspects different batch sizes each day, and you still want to monitor performance fairly, the P chart is your go-to tool. Let's reinforce our understanding of the P chart with practical examples from both manufacturing and service industries. Manufacturing example. A factory inspects batches of light bulbs, but the batch size isn't always the same. They calculate the percentage of defective bulbs per batch. Since the sample size varies, a P chart is used to plot the proportion defective. The P chart dynamically adjusts its control limits based on the varying sample size, allowing consistent and fair evaluation. Service. Example. An insurance firm audits a random number of claims every month. For each audit, they calculate the percentage of rejected claims. Here again, the P chart is perfect because the number of claims audited varies, and we want to monitor the rate of rejection. So, in summary, the P chart is your go-to control chart when you're dealing with binary outcomes, like pass, fail, defective, not defective, but the sample size isn't consistent. This ability to handle variable sample sizes is what sets the P chart apart from the NP chart. This slide acts as a quick summary for when to use the P chart, especially if learners need a visual reminder. You should use a P chart when you're dealing with binary outcomes such as defective, chahte not defective, pass, fail, or approved, chahte rejected. The sample size changes from one inspection period to another. Unlike the NP chart that requires a fixed sample size, the P chart is flexible and adjusts control limits based on the actual sample size each time. So, if you're inspecting different quantities of products or transactions daily, and you still want to track the percentage of failures or defects, the P chart is the right choice. It's especially useful in dynamic environments where inspection volumes can't be standardized. This slide gives you a clear side-by-side comparison of the four main discrete control charts, so you can quickly determine which one to use based on your process data. Let's break it down row by row. Row 1. Counts what? C chart. Counts defects, multiple possible per unit. U chart counts defects per unit. NP chart counts defective units pass or fail. P chart tracks the proportion defective. Row 2. Sample size. C chart and NP chart require a constant sample size. U chart and P chart can handle variable sample sizes. Row 3. Defects per unit. If your analysis involves defects per unit, go with U chart or P chart. For just counting defects or defectives, choose C chart or NP chart. Row 4. Data type. C chart and NP chart deal with counts. U chart and P chart are based on rates or proportions. Row 5. Examples. C chart, number of defects on a panel, e.g., scratches or soldering defects. U chart, defects per 100 meters of fabric. NP chart, number of defective widgets in a batch. P chart, percentage of defective applications in a variable audit size. This table should act as your go-to reference when deciding which chart fits your specific situation. Up next, we can look at common mistakes or quiz questions to test understanding. Now that we've learned how to choose the right discrete control chart, let's talk about how to interpret them effectively. When reviewing a control chart, these are the key signals to look for. Points outside control limits. This usually indicates a special cause variation, something out of the ordinary that needs investigation. 7 consecutive points all above or all below the center line. This is a red flag that the process may have shifted, even if those points are within the control limits. Trends, shifts, or unusual patterns. Any repeated, non-random behavior suggests something has changed in the process. These patterns help us answer the most important question in statistical process control. Is the variation we're seeing just random, common cause, or is it due to something special, special cause? If it's common cause variation, we focus on improving the system or process design. If it's special cause variation, we investigate the specific event or condition that caused it. This interpretation step is critical. It turns raw data into actionable insights for quality improvement. This slide emphasizes a very important takeaway: why selecting the correct control chart is critical. Choosing the wrong chart can result in misleading signals. You may think there's a problem when there isn't. Or worse, you might miss a real issue in your process. Here's a simple guide to remember. If your sample size is constant, use C chart or NP chart. OC chart for defect counts, ONP chart for defective units. If your sample size varies, use U chart or P chart. OU chart for defects per unit, OP chart for proportion. Defective making this distinction ensures your analysis is valid and trustworthy. The right chart type reveals the truth about your process performance, while the wrong one can hide it or distort it. So, the key message is, let your data type and sample behavior dictate your chart choice. As we wrap up this module on discrete control charts, here's the key message to remember. Discrete control charts let you track counts of problems, not measurements, and keep your process under statistical control even with count data. That's the core of it. Whether you're tracking defects, errors, complaints, or defective items, these charts give you the tools to visualize process behavior, detect unusual variation, and respond before issues become bigger problems. The beauty of discrete charts lies in their ability to provide statistical insight even when you're not measuring things like weight or time, but simply counting occurrences. Use them correctly, interpret them wisely, and they will help you drive process excellence in both manufacturing and services.